Every story starts with a question. And the greatest story of all, the story of science, began with a simple glance. Long before telescopes, before equations, before the very language of science existed, someone looked up at the night sky and wondered, what are those lights? Why do they move? What does it all mean? The sky wasn't chaos. It was a pattern. The sun rose and set with comforting regularity. The moon waxed and waned, a celestial clock. The stars returned in their seasons, marking the passage of time, guiding travelers, and signaling when to plant and when to harvest. From that simple, profound act of noticing, humanity began an incredible journey that would span millennia. This is the story of that journey. A journey from survival to understanding, from myth to measurement, from the shadows of ignorance to the brilliance of the stars. This is the first volume of our exploration, and it's not just a story about technology or inventions. It's a story of ideas powerful, transformative ideas that have shaped how we see the universe and, in turn, how we see ourselves. Our tale begins with the very first humans, our distant ancestors, who watched the heavens for signs of time and safety. Their lives depended on understanding the rhythms of the world around them, and the sky was their ultimate guide. From these humble beginnings, we move to the Fertile Crescent of Mesopotamia. Here, watching the stars wasn't just a pastime. It became a profession. Priests and scribes meticulously recorded the movements of celestial bodies, creating the first astronomical records, believing the fates of kings and empires were written in the heavens. Then we travel to ancient Egypt, where the cosmos was woven into the very fabric of society. The flooding of the Nile, the lifeblood of their civilization, was predicted by the rising of the star Sirius. Cosmic order wasn't just an idea. It was carved into stone, immortalized in the pyramids and temples that aligned with the stars, a testament to a civilization in harmony with the universe. The story then shifts to ancient Greece, where a revolutionary change in thinking occurred. The Greeks looked at the same sky, but asked different questions. They weren't just content to know what happened in the heavens. They wanted to know why. The sky became a puzzle to be solved, a challenge for the human mind. Philosophers like Plato and Aristotle proposed models of the cosmos, not based on divine whim, but on logic and reason. This intellectual fire spread through the Hellenistic world, from Alexandria to Syracuse. Here, the abstract geometry of the Greeks merged with the meticulous observational traditions of the Babylonians. Thinkers like Ptolemy synthesized centuries of data into a comprehensive model of the universe, a complex system of spheres and circles with the Earth at its center. It was a masterpiece of geometry and observation, and it would dominate Western thought for over 1,400 years. But this story of discovery does not belong to Europe alone. Far from it. While Europe entered a period of relative slumber, the torch of knowledge was carried across deserts and oceans. In the bustling cities of the Islamic Golden Age, from Baghdad to Cordoba, scholars not only preserved the ancient Greek texts, but expanded upon them with breathtaking originality. In places like Morocco and Al-Andalus, brilliant minds measured the size of the Earth, invented revolutionary instruments like the astrolabe, and critically, they questioned the Greeks. They found discrepancies in Ptolemy's model and weren't afraid to say so, armed with bold precision and new observations. Their work was a crucial bridge, a vital link in the unbroken chain of scientific inquiry. And then, that knowledge began to flow back into Europe. Through the quiet corridors of translation schools in cities like Toledo, Spain, Arabic manuscripts filled with science, mathematics, and philosophy were painstakingly translated into Latin. This infusion of knowledge helped spark a great awakening, a rebirth of learning we now call the Renaissance. This new era brought with it a new kind of courage, the courage to challenge centuries of dogma. A Polish canon named Nicolaus Copernicus dared to propose a radical idea. What if the Earth wasn't the center of everything? What if it too was just a planet orbiting the sun? It was a revolution on paper, a seismic shift in our cosmic address. This shift set the stage for the scientific revolution. A new generation of thinkers taught humanity to trust evidence over tradition, to test ideas with experiments. Johannes Kepler, through painstaking analysis, discovered the elegant elliptical paths of the planets. Galileo Galilei turned his newly built telescope to the heavens and saw things no one had ever seen before. Mountains on the moon, moons orbiting Jupiter, the phases of Venus. His discoveries shattered the old model and proved Copernicus was right. Thinkers like Francis Bacon and René Descartes championed new ways of thinking, new methods for acquiring reliable knowledge. From there, the narrative accelerates, the pace of discovery quickens. Isaac Newton, a giant among giants, unites the earth and sky under a single set of universal laws. The same force that makes an apple fall from a tree, he showed, is the very same force that keeps the moon in orbit around the earth. It was a moment of profound unification. A century later, James Clerk Maxwell would reveal another deep harmony in nature, uniting electricity, magnetism, and light into a single elegant theory of electromagnetism. He showed that light is an electromagnetic wave, revealing a hidden unity in the forces of the cosmos. Then, at the dawn of the 20th century, two new revolutions would once again tear up the rulebook. A young patent clerk named Albert Einstein would completely reshape our understanding of space, time, and gravity. He showed that space and time are not fixed and absolute, but are woven together into a dynamic fabric that can be bent and warped by mass and energy. At the very same time, another group of physicists was delving into the subatomic world, and they discovered a realm stranger than any science fiction. This was the world of quantum mechanics, a world of probability waves, uncertainty, and bizarre connections. It opened a door to a reality that defied all common sense. Each of these chapters, each of these breakthroughs, was a step toward greater clarity. But it's also a powerful reminder that clarity is never final. This isn't a simple, triumphant march of progress. It's a human story, filled with brilliance and blindness, courage and caution, breakthroughs and biases. Science didn't grow in a sterile laboratory, isolated from the world. It grew in a constant conversation, with philosophy, with culture, with faith, and always against the stubborn limits of human perception. This journey reminds us that knowledge isn't a ladder we simply climb to absolute certainty. It's more like a horizon that recedes as we advance, revealing ever wider vistas of what we still don't know. This first volume of our story ends here, at the dawn of quantum mechanics. This is a threshold where the comfortable, predictable classical world gives way to a new age of uncertainty, probability, and mind-bending possibility. Beyond this point lies the space age, the era when humanity would finally turn its gaze outward, not just to understand the cosmos, but to physically enter it. But before we take that next giant leap, let's take a moment to look back. Let's trace this incredible arc of thought that carried us from those first curious skywatchers, huddled around a fire, to the very edge of the quantum world. Because in their questions, their struggles, and their breathtaking discoveries, we find the roots of our own wonder, and we find the enduring promise of everything that still lies ahead. Thanks for joining me on this first part of our journey. If you found this fascinating, make sure you're subscribed and have notifications turned on so you don't miss the next volume. See you then.